This video briefly introduces the application of real-time multitasking operating system in AGI system. It is just a starting point. Please correct any shortcomings. In AGI system, most of them have certain technical requirements for real-time performance. For example, AGI main card, AGI basic controller, AGI enhanced controller, AGI real-time module, AGI general module, etc. A real-time operating system is an operating system that guarantees the completion of specific functions within a certain time limit. Real-time operating systems are divided into hard real-time and soft real-time. Hard real-time requires that the operation must be completed within the specified time, which is guaranteed when the operating system is designed. Soft real-time only needs to complete the operation as quickly as possible according to the priority of the task. Commonly used operating systems can become real-time operating systems after certain changes. The following is a brief introduction to real-time multitasking operating systems. A. Multitasking. Divided by whether the task is periodically changed during execution. A1. Periodic real-time task. The external device periodically sends an excitation signal to the central processor, requiring it to execute cyclically according to the specified period in order to periodically control a certain external device. A2. Non-periodic real-time task. The excitation signal sent by the external device has no obvious periodicity, but must be linked to a deadline. It can be divided into two parts. The start deadline. The task must start execution before a certain time, and the completion deadline. The task must be completed before a certain time. Task, also called a thread, is a simple program. Each task is assigned a certain priority, has its own set of CPU registers and its own stack space. Typically, each task is an infinite loop. Each task is in the following 5 states: sleep state, ready state, running state, suspended state, interrupted state. B. High precision timing system. Timing accuracy is an important factor affecting real-time performance. In real-time application systems, it is often necessary to accurately determine the real-time operation of a device or the execution of a task, or to accurately calculate a time function. These not only rely on the clock accuracy provided by some hardware, but also rely on the high-precision timing function implemented by the real-time operating system. C. Multi-level interrupt mechanism. A real-time application system usually needs to process a variety of external information or events. But the urgency of the processing is divided into priorities. Some must respond immediately, while others can be processed later. Therefore, it is necessary to establish a multi-level interrupt nesting processing mechanism to ensure timely response and processing of real-time events with a high degree of urgency. D. Real-time scheduling mechanism. The real-time operating system must not only respond to real-time event interrupts in a timely manner, but also schedule and run real-time tasks in a timely manner. Processor scheduling cannot be done arbitrarily, because it involves switching between two processes, which can only be done at a time point that ensures safe switching. The real-time scheduling mechanism includes two aspects. D1. Ensure that real-time tasks are scheduled first in scheduling strategies and algorithms. D2. Establish more safe switching time points to ensure timely scheduling of real-time tasks. E. Code critical section refers to code that cannot be divided during processing. Once this part of the code starts executing, interrupts are not allowed to be entered. F. Shared resources. Resources that can be used by more than one task. H. Task switching. Save the current state of the running task, all contents in the CPU register, in the task's own stack area. Then reload the current state of the next task to be run from the task stack into the CPU register, and start the next task. I. Priority inversion. The priority inversion problem is the most common problem in real-time systems. The allocation of shared resources can cause low-priority tasks to run first and high-priority tasks to run later. The solution is to use the priority inheritance algorithm to temporarily change the task priority to curb priority inversion. J. Mutual exclusion. Although the shared data area simplifies the information exchange between tasks, the exclusivity of each task in processing shared data must be guaranteed. General methods to meet the mutual exclusion conditions are: turn off interrupts, use test and set instructions, prohibit task switching, and use semaphores. K. Interrupt response time. Because the significance of using a real-time operating system is to be able to handle various sudden events in a timely manner. That is, to handle various interrupts. Therefore, The most important and representative performance indicator parameter for measuring a real-time operating system should undoubtedly be the interrupt response time. K1. Interrupt response time is usually defined as interrupt response time is equal to interrupt delay time plus time to save CPU state plus execution time of the interrupt service program of the kernel. K2. Interrupt delay time is equal to maximum time to turn off interrupts plus time to start executing the first instruction of the interrupt service program. K3. Maximum interrupt disable time. When the RTOS runs certain system calls, it will not be interrupted by the arrival of external interrupts. Only when the RTOS returns to user mode will it respond to external interrupt requests. The maximum time required for this process is the maximum interrupt disable time. L. Task switching time. When a task exits the running state for some reason, RTOS saves its running site information, inserts the corresponding queue, and reselects a task according to a certain scheduling algorithm to put it into operation. The time required for this process is called task switching time. Maximum interrupt disable time and task switching time are the two most important technical indicators for evaluating the real-time performance of an RTOS. M. Reliability. Real-time systems require high system reliability. Because any error may bring huge economic losses or even unpredictable, catastrophic consequences. Therefore, in real-time systems, multi-level fault-tolerant measures are taken to ensure the security of the system and data. And others, such as semaphores, mailboxes, message queues, memory management, interrupt management, etc. In AGI systems, in addition to real-time requirements, there are also computing power requirements. Computing power mainly depends on the main frequency and other characteristics of the central processing unit. For example, digital signal processing technology, DSP, floating point arithmetic unit, FPU, trigonometric function accelerator, TMU. Image processing accelerator, IPA. High performance digital filter, HPDF. Filter algorithm accelerator, FAC, etc. Please let us know if you have any doubts. We are willing to provide free technical support. At the same time, we learn from engineers. Thank you for watching this video. Goodbye.